There it is. Great, thanks. Yeah, work various integrations. Yeah, hello, my name is Evgenii Novozhilov, just for recording. That was the only missed part. Yeah, make compilation database, whatever else. Bazel, of course, as well. I started to work on the Bazel integration in CLion in the middle of 2023. And today we also have second talk from Daniel, who works also at this team. And Daniel joined in 2024. And we are trying to bring things, make things better. And nice to, okay, the video is here. And so the question to the audience, let's start from the brief thing. I have used Bazel at least once. At least once, great. At least twice. Okay. Then I do Bazel not only for C++. Great. And then I maintain internal rule set at XYZ company. Great. Okay. I'm contributor to any other public rule set. Okay. I've ever done Starlog debugging. Great. Great. Okay. Good. So yeah, let's start here. The contact details will be the final slide as well. So feel free to reach to me and to anyone else from JetBrains, from CLion team here today, tomorrow, any other day in Utrecht, whatever else you'd like to. So today we are going to discuss in my talk using Bazel for C++ and more. So this will be more of non-IDE related stuff. So what can it be used for if you never used it, if you ever used it, and maybe some other stuff here and around. So the agenda is that what is Bazel, what is Starlog, how C++ supported in Bazel, a note on tool chains and hermeticity of these tool chains, a note on extending Bazel. And the final one, extending Bazel, I have to this key point here that Bazel is a very extensible thing that can fit many other purposes. So, and right there, the modules support in Bazel. So you can see that it's still open for many years and it's not yet there. So, but that's the state of modules, whether are we there yet or not. So as an introduction, so what the Bazel is an open source build and test tool, similar like to make Maven, Gradle, give any other name here. And it uses human readable high level build language. So maybe if we can compare to CMake, at least maybe human readable is a challenge to CMake their language, for example. So on the language, we will have some slides later. Why is it human readable as well? So Bazel supports projects in multiple languages and build outputs for multiple platforms. So it's not like, well, sure, Gradle too supports with plugins. But well, for example, if you have ever used Gradle native, I guess Gradle native is no longer support. Well, is not that well popular state right now. And Bazel is pretty well scalable. Right. Various caching stuff, we'll touch that as well today. That why Bazel can fit, why Bazel is popular at the scale. So speaking one by one from the list there, so build and test tool. So you can build, run, test. You cannot debug. Debugging we will touch later as well. This is pretty obvious. And the open source model of Bazel, so there are two GitHub organizations around it. So Bazel Build organization and Bazel Contrib organization. So Bazel Build hosts Bazel itself, this tool supported by Google, and Bazel Contrib is community contributions. There is a technical steering committee. People other are involved from other companies. there. So libraries transferred from to the community from Google. So some things are not maintained at Google anymore, or maybe because of the high interest from the community. So the language that is human readable is a Starlark language that is used everywhere. So in a nutshell, it's like a Python, but maybe not a Python. So let's say it's with an asterisk, that it's a Python with asterisk. And it's also called a build language because all the files are called build. So that's a snippet from Starlark, which is pretty similar to Python. I guess it's like there is no other contracts. But there are some limitations. So it's a subset that that are designed to make it more performant. So with some limitations, this specification here about Starlark is in a separate repository on Bazel build organization. And also kind of worth mentioning that Starlark is also shared, for example, with other tools, if you have heard of Buck2, for example, and some other stuff. So they kind of share the specification. And given an abstract Bazel project, so there are several important files that you have to work with. There's like module Bazel, is this Bazel project definition. So forward, today we are not talking about legacy mode, which was before Bazel 7, which is kind of it was popular. There are many references to it, but let's do things right. Let's use Bazel mode. So I'm even not referenced to some other things except workspace on the right side there. So module Bazel is a definition of Bazel module, basically project. So build files, the package definition. So you have packages, well, similar kind of to Java, let's say. And the other files, so Bazel or Bazel dot, this a common, well-known extension, and workspace. Hope this year with the release of Bazel 9, the support of workspace file will be removed, and we will not need to remember that stuff anymore. So moving forward, Bazel supports projects in multiple languages and build outputs for multiple platforms. The already mentioned word rule set is a set of rules, in other words, commands that let you build your A into B. So not always code into binaries. So it depends on many things. So you can build Docker containers, Docker images, for example, and so on. This is a list from Bazel website, but it doesn't mean that, for example, there is a single rule set for Java or a single rule set for Python. So for Python, there are two rule sets, for example, rules Py and rules Python. So everyone can develop whatever you would like to. We will not touch rule set development today. Maybe it's more advanced stuff. So that part will be skipped today. And jumping onto C++. So to build C++ code with Bazel, there is a rules CC rule set that was originally built in Bazel and eventually published out as a rule set, as a repository on GitHub. However, implementation inside, it still primarily uses built-in Bazel functions, but Google is trying to move from internal Bazel implementations into Starlark type rule set, because any Starlark rule set can be updated without releasing a new version of Bazel. So this kind of that's like the contract, the separation. So anything that is developed for Bazel, so that comes with Starlark, can be updated separately. Then you also get some maintenance hell that like you have to support Bazel 6, Bazel 7, Bazel 8, some kind of versions, let's say, and then kind of it doesn't work with one, it works with other, and it conflicts with the other rule set. So kind of welcome to this world. But that's the state of it. And to be able to compile C++ files with this toolset, by default, it provides you local toolchain after discovery. So there are some, like with CMake, that CMake is capable of searching for C and C++ compilers and other stuff. The same exists in Bazel. And it kind of a bit contradicts with the idea of Bazel, of the Hermitist being able to provide reproducible builds. So it can be disabled. And maybe I would say it should be disabled. So that's a recommendation, kind of a note here. So just a moment. All right. So if you have any questions, we have time for questions at the end. So let's just do it that way. Speaking of the files and the structure, so as I mentioned, the project definition, module definition, that's in the module Bazel file, and it's not that much to start from the scratch. So just define your module, your version, and bring the dependency on the rule set that you would like to use, or on anything else that you would like to use. So it's not limited to rule sets, but starting from Bazel 7 from year 2023, we have Bazel Central Registry, accessible at registry.bazel.build, where all the rule sets and other tools are published there. So this is also maintained from the GitHub repository. You can submit PRs, share code with the others. So that's kind of snippet there. So maybe not just up to date. So rules Node.js, rules Py, rules whatever else there is available. And there is a process of submitting PRs there to get tools published there. So it means that whatever you publish there can be accessed just with Bazel dep statement in module Bazel file, which declares your dependencies. So maybe, I don't know, if someone have used Meson, there's a wrapdb, for example, and well, maybe from CMake, this is more like, not really like external project add, but something similar. So, and also it supports, Bazel supports custom registries. So you can host your internal registry with internal tools somewhere and just provide it as an through the flag to your Bazel build here. And even going further, Bazel supports thing called vendor mode. So you can have offline builds, you can prefetch all the dependencies, external one, and kind of have to have some builds internally offline without internet, without someone else. So kind of for some enterprise scale. So sometimes this kind of popular stuff also compared kind of in addition to the Bazel to the internal registry. All right. So and then going backward a bit, module Bazel. That's what we had, and okay, so there was duplicated slide. Sorry. The build file, the second mandatory part there. So instead of importing in Python, we have load statement here, which is a bit ugly. So Bazel operates with the concept of labels. Concept of labels. So we have workspace name. So after the at mark, there is a workspace name, and then kind of two slashes. That means that this root of that workspace external, and then goes to the some package, and after colon you denote something inside the package. So, and as mentioned, the package boundaries are defined by the existence of build file. So, and just to compile a single file in C++, you need only 5 lines of code. In addition to two, let's say, kind of 2 lines of code in module Bazel. So not that much still, but yeah, it has to be said explicitly. So when given this input and some main file, you can run a main, you can run native binary straight from Bazel. So, and as I mentioned, it used like local toolchain after discovery. So it just discovers something that is available on the machine where the Bazel is running. So in the simplified version, but everyone can define anything supporting compilation for C++ with CC toolchain function rule that is coming from rules CC. Also toolchain that is kind of Bazel built-in native. So things are scalable, and you can define toolchain for one platform, for another platform, for some other platform. So Bazel is internally supports information about platforms, the current platform, the target platform, and Bazel can pick up the toolchain based on the conditions, like you see they're exact compatible with, target compatible with stuff. And it's not only for C++. So toolchain is used also, if I remember, for Java, for JVM as well. Things you can define cross-compiler toolchain, for example, there, or you can define two toolchains to the Bootstrap toolchain to build cross-compiler and so on and so on. And there are some open source toolchains already available. Just worth mentioning, I guess, LLVM toolchain that kind of you can just get some LLVM pre-built binary, so you don't need to build it yourself. So it can be downloaded. Or there's like Hermetic CC toolchain from Uber. Kind of basically is based on the Zeek. So things are published on the GitHub and also on Bazel Central Registry. So in this example, then we are moving forward. We just would like to bring the toolchain to use not the local auto-discovered one, but just some kind of shared one. So it requires kind of yet another 5 lines of code, so we can to specify the versions and whatever you would like to use. And then you just have to register it. So you can write your own. So this all done with the code from the GitHub. So you can write the same for your own toolchain and so on. And in CLion, for example, we support such a kind of configured toolchains separate automatically. So kind of on this screenshot, we can see that kind of the header, standard library header, is pointing to toolchains LLVM, LLVM toolchain, and so on there. So CLion is capable of working kind of introspecting this result, getting this result from the introspection, and this will be covered by Daniel later today a bit more in detail. So we said that there is a rules toolchain, a rules CC toolchain for C++. Then we have several items from it: CC binary for binary elements, library for library, CC test for unit tests, and CC toolchain just to register your own toolchain. So moving forward from assembling and building and running to testing, popular libraries are also hosted on the Bazel Central Registry, Google Test, Boost Test, Catch2. They are available there, and you can get them to your project with Bazel Dep again, Bazel Dep Google Test at the bottom with some particular version. And the targets from this toolchain, from this dependency becomes available to you. So if you're writing some test, then you just depend on gtest and gtest with main if you need main function from Google Test. Then you can just do Bazel test, and it does the testing out of the box. So it kind of compiles Google Test and does everything as you would like to do. And sure, you can launch tests even without Bazel. So there is kind of, you can access them through convenient symlink code stuff. So by default, they are Bazel dash. They are created automatically in the project root. So you can access from Bazel binary directory. So they are published there. You can launch it directly if you would like to. And then let's introduce the feature of Bazel of caching. So in a very simplified way, you can have cached results. So if you run something with the cache configured, so let's say here we use this cache for builds. Kind of first you run, you get test passed, You do it second time, it says cached. So actually it's not run. So because it was a cache hit. So on the cache, we will just have a note a bit later because it's pretty long topic. So given that we have done building, running, testing, the next phase is, I guess, debugging. So you can do this externally, sure, by accessing the artifacts from the build directory, or you can do it with things like run under GDB server and maybe whatever else. So Bazel just provides an arbitrary command to be injected for running your program, or you can use Selenium to do that. Kind of example here that the Google test stuff is being debugged here just by clicking debug button in CLine. So CLine supports it out of the box with a little note in 5 minutes. And then, so running, building, testing, debugging, discover it. And then note on non-Bazel depths. You can bring anything to Bazel by using, let's say, HTTP archive or Git repository function, so from outside of the Bazel world, and you can feed some build file to that tool, kind of provided by you externally. For example, you wrote yourself, well, maybe importing something, maybe, well, for some simple stuff, you can write it yourself. And if the repository is not accepting build files, so you can feed this externally. Or maybe someone is already maintaining the build files for the project to be imported. And also a note on non-Bazel depths that there is a rules for NCC that can give you an option to build make applications, CMake applications, and whatever else. But kind of, if we are speaking of being Bazel, maybe it's better to have everything in Bazel and not call CMake CMake from Bazel or make from Bazel and so on. So, and as I said, the cache, Bazel, it depends how to count. Bazel provides like maybe 3 to 4 or maybe even more levels of caching. So that's kind of to bring this, to make it efficient, to make it scalable. So we can say that the first level of cache, maybe it's just StarLark evaluation. So if you don't change anything to build files, to StarLark functions, so it's not required to be interpreted. StarLark previously was called Skylark. So then reading Bazel source, you can see that there are Sky function stuff, something else with Sky. So it's kind of replacement for Star. And down to artifacts cache. So whatever is built. So if rule inputs are not modified, if any state is not modified, as we saw, for example, with this Google test. So example, then it was not rebuilt and it even was not rerun. And then, for example, for the dependencies that you have here, we have listed in module Bazel file. If they are not modified externally, they are not re-downloaded. So kind of you don't need to download them any other time, except if something is being changed in their definition. And a little note on Ccache here. I was asked once, like, kind of, can Ccache be brought to Bazel? For example, let's say you have a library with 10 files, and then you modify one file, compilation unit. Then do you kind of, we can reuse Ccache because then we don't need to recompile 10 other things. Bazel uses concepts of sandboxing. So to bring this hermeticity, that you don't access anything that you are not supposed to access, local auto-discovery toolchain, let's say, exception. And then you are not allowed to write to an arbitrary locations, again, to not modify the state. This works probably on Linux only because Bazel is integrated with namespaces. So to prevent the access, so you can get either read or write and other stuff. So, and CMake cache by default, it's in a home directory. So it will fail by default to write. But you can do this stuff technically. I mean, to do this properly, not by allowing to write to sandbox, but maybe it's still a question: is it desirable? Do we really want this, or don't we? So it's an open topic in my opinion. So maybe someone would really like to do this stuff. So, and then we're going to let's say some C++ specific things from Bazel that we see. Let's say with an asterisk that there is a single CC toolchain for the project. So for the project that is being assembled on the current computer first, and we're not going here to remote build execution, so that's kind of something is built on some other. So on the current one, the rule is that like it's one, but you are allowed to do things called transitions to change the tool chain for some targets. So if you, let's say, if you would like to have one tool chain to compile artifacts for the current computer architecture and one for cross, you can do this stuff with transitions. So to apply this stuff, it's said that transitions has performance implications. Let's say accept it as a truth item. So kind of consider this stuff if you would like to apply them. There is a pretty long article in the Bazel documentation of any side effects of transitions. Also, Bazel, for example, supports to suppress warnings from external headers, because the idea is that you usually assemble everything, and when you get some header from some other project, you compile it in your one, so you get warnings, it doesn't work well. So there is a feature to say that external include pass, and you can do this. I think the same is possible in CMake, but I kind of just forgot how it's possible to do this in CMake. And then note on C++ standard specification pitfall. I think when you would like to compile something with some particular standard, in Bazel there is still 3 options. No one is really recommended, so feel free to choose whatever you'd like to. Yeah, that's kind of how it goes there. But I guess maybe Bazel or C1 would be the nicest. So at least you define it for your project. So the ERC file. And then on the extending node, last year at BazelCon 2024, there was a very interesting talk about defining your own tool chain given by Salesforce that addresses interesting things with the hermeticity, for example. So, for example, we can say that, imagine macOS. macOS requires macOS SDK libraries for your software to be built. They are not distributed separately. You are not allowed to distribute them separately as well, because they are governed by Apple license. And you cannot build macOS binary without them. So unfortunately, there's a proposal how you can how you can mitigate this thing. How can you get them to your project to be able to get reproducible builds for macOS as well? Because your Xcode toolchain is changing, build is no longer valid. So, and this like the dependency that is not mentioned by Bazel. So the concern of reproducibility. So this is pretty interesting talk to check. And then unrelated to C++ and whatever, the starter kit for Bazel, for the tooling. So nice things. First, Basilisk, user-friendly launcher to Bazel. You can get away any version of Bazel you would like to run in your project. And also you can try to test your project against Bazel it had. So the next version of Bazel that will be eventually released, any beta and whatever else. You're also provided with buildifier, the formatter for build files. And for example, C-Line also is integrated with this buildifier, so it can invoke buildifier on save. So all your build files should look similar, have the same style, and then bulldozer for doing command line operations on build files. So some hints can be automated, do something like that with bulldozer, and there is nice tooling provided. So then things to consider, and let's maybe speculate a bit. So it's actually Python interpreter written in Java with several levels of caching, other stuff. So there is a magic happening under the hood, basically. The other stuff is that Bazel follows daemon approach like Gradle, and you have this daemon running like after CMake. So like, you run CMake, it tags, nothing happens. This stuff is in Java, it's hanging in the background, and then it's also left to eat your memory. And also it depends how large your project and what exactly is in your build rules. And then contributions to Google modules might be challenging or are challenging. You have seen the module support. There is still no module support, but maybe it's because of modules. Anyway, so something that, because these rules can be also used internally at Google, and you have to negotiate this stuff with Google and so on. So I don't know what was the reason for rules pi, but for example, we have rules Python, rules pi, as I mentioned, and yeah, that's kind of things that can happen. Starlark expertise. Yeah, maybe Python expertise, kind of it exists, but then immutable collections, some immutable collections, some other things, not a lot. So the load should be, you can have dynamic load, so they also have to be in the beginning of the file, and some other stuff. So this is like a bit special thing to find. And future of Bazel, this year, I hope we will get Bazel 9, because like last year, Bazel 8, it had 8 probably release candidates, and it was the release was 1 or 2 months late beyond that. So what will be the future then? Who will be maintaining that? So Google is interested in maintaining that, but also Google is interested to push this tool to the community. We know that, for example, BazelCon in 2024 was finally organized by community in with help of Google, but still, so this the BazelCon was moved to community. And what will be the future? Who will be supporting this Java code? A lot of Java code so runs on JVM. That's a question. So to finalize, yeah, here we have C-Line that works with Bazel, and you can use for your experiments, and the promotion of our plugin Bazel for C-Line that is published by Google so far. Hope soon we will publish it under JetBrains name. That we release every 2 weeks. The plugin is open source. It's available on the GitHub at Bazel Build IntelliJ organization. You're welcome to contribute there or to try it out from JetBrains Marketplace. All the sources for these presentations are available in my GitHub repository, johnny/BazelCpp. And should you have any questions, feel free to write this to en@jetbrains.com. So that's my email and not English language support. Yes. So here we are. What's good? We're on time. We have time for questions. So, and remember, we have 6 codes. So it's going to be fair, like 3 for me, 3 for Daniel after Daniel's talk. All right. There. Great. Would you? Okay. Good. Thanks.
So that we record the questions, I will come with the mic.
Hey, thank you for the. Not sure.
I'll bring that to you. Listen to the question.
Yeah. Okay. First, thank you for the talk. Nice talk. I think it's these are some plugs. So with the
Thank you.
we talk about Bazel registry, a lot about external dependencies, which was somehow right now basically the common place to use it for everybody. But CMake projects we have right now, or make projects or Mason, whatever who use, we have a lot of dependencies, which is very difficult to switch to Bazel very fast. And does Bazel support something like VC package support or Conan support, something which is already built or can be already built by other systems, and use ready binaries from the Bazel? Because, for example, if you have, I don't know, Boost, it's very difficult to get it with Bazel because it's very huge library, and writing Bazel scripts can take infinity. So does Bazel has something to support ready binaries package managers or something similar? Thank you.
For binaries, to be honest, I don't know the answer for binaries specifically. So I know that for JVM libraries, you can import them into, so like from the jar files, for example, and I mentioned rules for NCC that you can use to build from source your dependency. And for the integration with VC package and Conan, I've never heard of that. I'm sorry for that. And I have to say that maybe it would kind of be against the concept of that you build everything from the source. Kind of, but Boost. I think Boost is on a Bazel central registry, so you can get it like Google Test, and you don't need to do this. Yeah. But maybe in our case it was. So there was a hint on CC import, similar to Java import. But maybe for Java import, this kind of common to import. I don't know how common is to import CC native binaries. All right, let's go. What's the answer? Good. Okay. Thank you.
Who's next?
Thank you for the talk. So I wanted to ask you about the how exactly does Bazel choose the tool chain for a specific rule, and how is it possible to switch between them while testing?
Thank you for the question. So you can, for example, Bazel provides by default platforms, and you can this Bazel built-in. So you can from the command line. So in Bazel or C file, you can define profiles. In these profiles, you can define a common set of arcs. So for example, this will be like architecture and something else and so on. And you can introduce your own constraints there. So from the command line flags, you will be telling like, what would you like to get? What against would you like to build? And then let's say some of your targets can have target compatible with, so with matching some criteria for something else, then kind of the toolchain just will be changed internally. So, but I think that kind of, all right, never mind this stuff. So that's the thing. So Bazel provides, so a long ago, a note here, ancient stuff. So there was cross tool things, and other stuff. So eventually it was rewritten, and the platforms are, in my opinion, much more friendly than the old approach. Thanks.
Yeah, thank you for your talk. And you mentioned building from source as the guiding principle. How does it work with CI? And yeah, how do you, well, if you are constantly building from source, how do you control for CI costs? And yeah, and the second question is on what scale does it make sense to to transition to migrate the existing project from CMake to Bazel?
All right. So second question was the transition from CMake to Bazel. First question was the CI costs. So let's start from CI. I mentioned there is a caching mechanism built in. So technically, if nothing has changed, nothing has to be rebuilt. So your CI publishes the result, the binary artifact, not just binary artifact, many things. It publishes somewhere, so you don't need to rebuild again if nothing has changed in your third-party dependencies. So kind of you build it only when you update your third-party dependency. Yeah. So, and then the transition from CMake to Bazel, it depends on many factors. So, for example, right now at JetBrains, we're doing Bazel migration for IntelliJ IDEA and other products because we would like to have a single build tool to build many sources from many languages in our monorepo because we don't have it yet. So we started this project half a year ago, and we are still doing it. So that was our main kind of intention for that. So maybe there would be other things, for example, that your project should be a part of monorepo which is built with Bazel, so like this. But for CMake CMake fits some needs. I'm not saying that CMake should be replaced by Bazel as a rule. All right, good. Last.
Who's first?
Hi, thanks for the talk. Sorry, my understanding might be limited here, so just bear with me. So if I understand correctly, CMake uses generators to create files that are then used to build. So you can either use make files or Ninja to basically create build files. So is it theoretically possible ever to basically have Bazel as a generator for CMake? Then you can just use CMake, which is already available for majority of the projects, but still get the benefit of Bazel. Like,
nice. Well, that's an amazing idea. To be honest, kind of worth trying. Sure, why not? But there's just one thing. So we know that Ninja is not supposed to be written by a human. It's even the computation of Ninja. So kind of if you ever try to write the Ninja build rules, this is kind of painful. So it's meant to be generated, and I guess that the Bazel files are not meant to be generated, for example. And well, maybe you will. It will be just a single call, kind of. Well, whatever. So sure, everything is possible. Yeah, nice idea. Thanks, Karen.
So there's a build file generator for Go, Java, Python called Gazelle that can generate build files. So is it available for C++? That's the first question. And the second, can you elaborate a bit on how a compiler upgrade would look with Bazel? So you explained toolchains, but you said only one toolchain is available at a time. So how you will upgrade a compiler for your code base?
Think about an answer while I'm getting back.
Okay, so first question was for the Gazelle. Yeah, so there is a tool called Bazel, so you can run Gazelle on your code base and it will generate files. I guess it was initially given by Go developers. So I haven't seen this for C++. I don't know if it exists. We were trying to write our own Gazelle because extension when we're trying to migrate our kind of internal build system to Bazel, and we haven't went that way, so we just made an external generator instead of this. So maybe just it's not public for everyone. It doesn't mean to be shared public for everyone. So yeah, I just don't know. Actually, this feature of Java, why it works for Java, for Go, because kind of the convention on the at least for the file system, if I understand correctly. So maybe for C++, this will require also some convention there that's kind of not common. So we don't have any well-defined order to store the file. So I'm not aware of that. And regarding the toolchain upgrade question, I'm sorry, I didn't get what exactly was the toolchain upgrade. So like, what actually happened? Compiler version, yes. So if you update the compiler, so you mean like kind of, would you like to say that kind of I changed the version of LLVM toolchain in my module Bazel? So you change it and then you are welcome to fix any issues that kind of occur with it. So just it's being rebuilt. So it's like it depends. So kind of what actually is the thing there with the upgrade? Because it's like, yeah, okay. So kind of that you have a project and then kind of you would like to upgrade compile, but other developers are doing some stuff and you would like to no. I think yeah. Revoke Git permissions from everyone, sure. Kind of, but I have a feeling that this you can register multiple toolchains and then you can just select with your config settings whatever you would like to use and kind of just make a profile with default settings and maybe just change the version later there. I'm unsure if it will work. Kind of this works for external libraries, for example. Whatever I tried there with config settings, so like kind of you can make default way. So I don't know if this will work for toolchains. Maybe you know. Okay. Yeah. So right? Questions?
Thanks for the talk. And that was a great introduction into Bazel. And my question is regarding caching. Am I right that all that comprehensive levels of caches that exist in Bazel, they are somewhat tricky to enable for C++, because in C++, like there is a C cache, but what it does internally, it preprocesses the whole translation unit and checks that the content hasn't changed, and then it can reuse the binary artifact. So Bazel would need to have the similar tool implemented inside for C and C++. Or, well, I actually talked to Daniel in private, and he told me that there is a tool that creates Bazel target for every header file. And so there is a whole graph of all dependencies. And what is the right approach to enable a native Bazel caching for C++?
All right, thanks for the question. And so we have to say that caching is language, whatever independent. So you just operate with the terms of inputs and outputs. So then that's how it works. So we can calculate the cache for the action result, so kind of to not do the action again. Or we can, for example, calculate action one. Okay, no, that's another story. But for so for C++, it's like it's still not on the level of like C cache. So C cache is a pretty kind of language specific implementation because it's kind of aware of this pre-processing of the file. So that's what doesn't exist. So like you just recompile the whole the whole library or the whole target, and then you just try to make your targets as smaller as possible. And then again, like Daniel mentioned, the generator for one file by file. Yeah, I've seen, for example, examples where there is one Bazel target per one Java file, for example. This is, in my opinion, a bit of madness, but that's something is doing. Now, so the caching is on the level of inputs and outputs. So for any target, so like you have sources. If you don't touch the sources, it's not rebuilt, it's cached. Okay, so that's the header files. That's why there's headers attribute, for example, on C0. So you have to tell. So again, this, for example, that you are supposed to access what you declare in your configuration. So then, for example, you have you use some header files. Probably they are part of some other targets on what you depend. So then, if that is those header files are changed, that library is repackaged, for example, and then only your target is rebuilt. So that's the flow. So basically, think like you have in CMake you have target link libraries. So that's you have one or the other. Okay. Okay, good. We can discuss it off pizza.
Thanks for the presentation. So CMake has more flexibility with its language. It's also harder to reach the bug, but with its power, you can also automate tasks not related necessarily with the build. So packaging, deploying, signing in some projects. Does Bazel also provide this kind of flexibility, or it focuses only on the build and expects you to use something else for these other tasks?
Oh, thanks for the question. You can package, you can define your own. So maybe speaking like by default, You anyway define something like what you would like to, the steps for install in CMake, and also there are some hints that you have to write explicitly these statements in the install, because otherwise something is leaking somewhere else. I guess there are some rule sets available. So for example, that we developed the plugin for CLine. It's fully built with Bazel. So eventually we get zip file as a result of Bazel actions. So, and this is just a define. So your action has an implementation. You can write code there. So run any binary, any tool, whatever you would like to do. So, and then package as you want. So I'm not really sure, but I guess some of the definitely Google applications on Android, they are packaged with Bazel, for example. Yeah, thank you for the question. All right, there was one more there. Good.
Thank you for a great talk. What would it take to add an extra build step? In particular, I'm thinking about you have some source files in a specific format, say XML, and you have to convert them to, say, C++ with a specialized tool. What would you have to do to do that with Bazel?
So you basically would like to convert XML to C++ and compile it. Sure. Yeah, so that's possible. You just define your rule that kind of generates C++ from XML. You write XML as an input, and then you say CC binary and sources. You will provide something like comments comes from there. So this like in the very common thing in Bazel, there's a rule called gen rule. So you can generate arbitrary content and then refer to it. So, and again, the result of that could be also cached again. Speaking of cache, so kind of your converter will be run only once. So if your tool that converts and the XML is not changed, so kind of Bazel will just download the file already generated from the XML. So this is possible. Thank you. All right. Guess we don't have any other questions because we have 10, 15 minutes. 3 winners. Yeah. Okay. All right. So 3 questions. Yes. All right. So that's the first question goes to first question about external tools. Right. Okay, we have 2 more. Let me. So I'm trying to remember what was the questions. Yeah. So and then the question. What was the questions? No, actually, last one on. Hold on. Yeah. The generating Bazel files from C. Make sure this kind of for the. Yeah, there. Right. And then let's say for toolchains upgrade. Go there. All right. So we are done. Thanks, everyone. All right. Great. Let's have a break. And we're back at 10 minutes. So we started 15.
Yeah, so let's make 10 minutes break till 2015. You can have a drink. Don't forget that you can't get with the drink back. So 10 minutes.